All right, so we are going to start with chapter 3. And we're going to specifically begin with 3.1, which is all about radian measure. This whole chapter is essentially about radians because we've talked so much about degrees. And so we're going to be creating our unit circle during this chapter. So radians is just, think of it as another way to measure angles. So radians is another way to measure angles. Okay, and instead of using degrees. So instead of degrees. So that's why it's really important to, when we talk about our degrees, to make sure that we use our degree symbol, right? If I'm talking about 10 degrees, so sine of 10 and sine of 10 degrees, this would be considered a radian, while this one would be considered a degree, and they will give us different answers. Okay, another reason why we use radians is because then we can treat our domains as real numbers, right, rather than angles. Okay, so what's the definition of a radian? Okay, so let's get to that. So we can say this: an angle with its vertex at the center of a circle that intercepts an arc on the circle equal in length to the radius of the circle, has a measure of what's known as 1 radian. All right, so what am I meaning by this? So let me just draw an x-axis and a y-axis for you, or y-axis first, then x-axis. So here is, so an angle with this vertex at the center of a circle. So let's draw a circle to the best of my ability. And that is a bad circle. So let me see if I can redo a little bit of it. I'll fix it up over here. All right, that's a little bit better. So our definition of a circle is that if this is our center right here, I should be able, the radius of my circle, so this little radius guy right here, so from here to here, okay, it's the same length from here to here, here to here, here to here, or any ray that I draw. So this guy from here to here would be that same measurement. Okay. What we're also saying is that if I take this distance, right, from here to here, and I say that that's r as well, and this distance from here to here, and I put a little theta in here, and I'm going to say my theta is equal to 1 radian, okay, then this guy, this arc length right here, is also equal to my r, to my radius. Okay, so basically this radius, and this arc length are all going to be the same. That is essentially what 1 radian is. Okay, but what is a radian in terms of a degree? Like how big is this? So let's think about a circle, right? So here is again a lovely circle that I drew, and if I wanted the distance around, right, which is called their circumference, and I know that that's my formula is c is equal to pi r squared. Okay, so let's just say that r is equal to 1 in this circle, right? Let's pretend that that's the center, so r is just equal to 1. Right? So my circumference, so from the start all the way around, right, would be 2 pi. So that's a full rotation. Okay. And so I know that 360 degrees is also a full rotation. Okay. So if I know that those two are equal to each other, right? 360 degrees is equal to 2 pi, right? These are my degrees, and these are my radians. So radians is usually dealing with pi. Okay, what happens if I decide to divide everything by 2? Right? What's half of a circle? Right? So I know that half of 360 is 180 degrees. Half of 2 pi is pi. So I know that every 180 is a pi. So again, from here to here is a pi. Okay, so we're kind of getting the idea. If I want to say one more time, I want to know what 1 degree is, right? I could, let's divide everything by 180, right? If I do that, I know that 1 degree is going to be whatever pi over 180 degrees, okay? That's going to be my 1 degree. Now, I want to know, right, what is 1 radian worth? Okay, that's what I actually want to know. So let's take it back to this equation where I said 360 degrees was equal to 2 pi. And if I divide both sides by 2 pi, essentially 360 and 2 will give me my 180. So really I'm just dividing 180 by pi. This will equal 1, which is 1 radian, right? So I'm going to grab my calculator for just a second and turn that guy on. So if I take 180, essentially, and I divide it by pi, this is what 1 radian is really worth, right? About 57.3 degrees. Okay, that's really what 1 radian is. So 1 radian is equal to 57.3 degrees. Okay, good to know. We don't really need to necessarily remember all of that specific stuff. Okay, but what we do want to do is we want to use this information right here and this information right here to help us convert back and forth between radians and degrees. Okay, so that's what we're going to work with. Okay, so convert to radians. Okay, so let's convert to radians, and we're going to do our first problem, which will be 45 degrees. Again, we are familiar with 45 degrees because eventually we're going to find the sine of 45 degrees. Now, 45 degrees is less than 57.3. So how do I go about doing this? What I'm going to do is I'm going to take my degrees and I want part of it. So I'm going to multiply by my pi over 180. Okay, so if we remember, 1 radian is equal to 180 over pi. 1 degree is pi over 180, which means that 2 degrees would be pi over 180 plus pi over 180. 3 degrees, 4 degrees, so forth and so on. So instead of adding up all those numbers, we're just going to multiply. Okay, so 45 goes into 180. It should go in 4 times, but let's just double check. And it does. So this means that we are going to get pi over 4. So pi over 4 is my radians, and 45 degrees is my, obviously, my degree. Now, we said that 1 radian is equal to 57.3. Notice that 45 is a little less than 57, 0.3. So notice what happens when I do pi divided by 4. I should get a little less than the number 1, right? Because pi is 3.14. I'm dividing it by 4. And notice I get a little less than 1.78. So it's important to kind of remember, how big a radian is and things like that. All right, let's try second example. And we want to leave it in pi over 4. That's our exact answer. So let's do 30 degrees. So that's another one that we work with. 60 degrees is another one. So 30 degrees times pi over 180. Again, this is going to be a lot smaller than 1 radian. My zeros are going to cancel out. 3 goes into 18 6 times. So this will be pi over 6. And again, radians. We are always going to assume that if we don't have the degree symbol, that we are dealing with degrees. One more. Let's do 249. Let's just say 0.8. Right? Let's be crazy. So obviously this one I'm definitely going to have you guys use a calculator for. Okay? Because we're not going to know exactly what 249.8 divided by 180 is. So let's do this. So 249.8. Let's multiply that by pi. And then I'm going to divide that by 180. And I'm going to get 4.35. So we'll round to 4.36. So 4.36 radians. Now, a complete circle, right? So 2 pi, if you think about this, is a little more than about 6, right? Because, again, notice that what 2 times pi is, right? 6.28, 283s. Notice that we are 4.3. We're almost at the complete circle. And 2.49 is in the third quadrant of our graph. What we can also do is we can convert to degrees. So it's important to go back and forth, convert to degrees. So 9 pi over 4. Okay. Again, be thinking about what 9 pi over 4 could be. If I know that 2 pi is a complete rotation, right? Complete rotation. If I multiply top and bottom, that means 8 pi over 4 is, the same thing as 2 pi. So that means that my answer is going to be more than 360. Again, important to remember. We are then also, since we are given our radians, we are going to use the other formula, 180 over pi. So essentially we want to get rid of our pi. So I'm going to multiply 180, right, by my pi. So my pi's and my pi's will cancel out. I've already done the 4 and 180, so I know that this will be 9 times 45. So again, if you need to use the calculator, 9 times 45, that will give us 405 degrees. So we're a little bit more than 360, like we said, and the 405 is actually going to be in the first quadrant again. All right, let's try another one. Let's try 4.25. So radians to degrees. And again, I'm just going to multiply that by 180 over pi. That is my dog barking in the background. This will be a calculator one for sure. So 4.25, multiply that by 180. And then divide that by pi, boom, get our answer is a little bit more, 243.5, right? Which if you think about what we already done earlier, right, it's pretty close to the 4.35, so one of the problems that we had done earlier. All right, so 243, what was the decimal? 0.5 degrees. Our next video is going to be how we can find the exact function of specific trig.